So we've talked in the past about congruent figures, congruent triangles mostly, but also congruent just polygons in general. And today we're going to get into similar polygons instead. It's a very similar concept, but not quite the same. And there are some extra things you need to be aware of for similar polygons. So let's go ahead and jump in. Two polygons are similar if their angles are congruent and the corresponding sides are proportional. Now, you might not remember what the word proportional means, but it means you can set up a fraction. This fraction equals this fraction. So you can have two fractions and they're going to be equal to each other, whether one is the reduced form of another or both of them are unreduced forms of some other fraction. When we're drawing similar, when we're writing similarity statements, the symbol for similar is just that little squiggle. It's the piece that goes above a congruent sign, but it's just that one symbol. So if you look at our two figures here, you can see we have some corresponding angles that are going to be congruent. So A and E are congruent. Notice figure ABCD and figure EFGH are not the same size at all, but they are similar, and you'll see why here as we do these angles and sides. Angles B and F are congruent, C and G, and then D and H. It's hard to get 4 arcs in there for those congruent angles. So just do your best on that. Okay, and for our sides, remember the corresponding sides form a ratio, form a proportion with the others. So we know that if we did AB over FE, it would give us the same number as if we did BC over FG. That would give us the same thing as if we did CD and GH. That would give us the same thing if we did AD and EH. So it doesn't matter which sides we use, we're still always going to get that same proportion. We're going to be able to reduce all of them to the same fraction is essentially what we are doing. But before we get into the actual fractions and stuff, because I know you love them, let's just look at these two triangles. Let's list our congruent angles. Now, this is our similarity statement. And just like with a congruency statement, we could use that to know what angles go together. So R is listed first in the first triangle, X is listed first in the second triangle. So we know that angle R and angle X are congruent. So we can mark those in our picture if we want to. S and Y are listed in the middle. So we know that angle S and angle Y are congruent. So we can mark those in our picture. And then T and Z are listed last. So we know that they are congruent. So we can, of course, mark those congruent. Now, when we get to our sides, it's a little more complicated than that. We want to check that the ratios are equal. The way we do this is basically to reduce all of our fractions and make sure we get the same fraction every time. So RS, that's the first two letters in the first triangle, that is 20. XY is 12. Now, it doesn't matter whether we've got 20 over 12 or 12 over 20. Either way, we're okay. But we want to reduce that. Now, in your graphing calculator, it actually has a way to reduce fractions. So if we did 20 divided by 12, because remember, fractions are just dividing problems. Top divided by bottom. That's going to give us a decimal. If we click Math, and then this says we want to change it to a fraction. So Math, enter, enter. It's going to change it to 5/3. So 20/12 equals 5/3. Now, ST and YZ go together. ST is 30, YZ is 18. So if we put that in the calculator and reduce our fraction, it is also going to give us 5/3. And then finally, we've got RT and XY. RT is 25, XY is 15. And if we reduce that, if we put it in our calculator and do math enter, it's going to give us 5/3. So since all of these give us the exact same fraction, we know that they are, their ratios are equal. We say that they are proportional, because we could set up a statement where we say 20/12 equals 30/18 equals 25/15. We could also write it using the names of our statements. So that would be RS over XY equals ST over YZ equals RT over XZ. This is, and this is actually our next thing. The statement of proportionality, I'll rewrite it a little bit larger, is when we have the names of all of those sides set up as a proportion. So I'm going to rewrite it a little bit bigger, make it nicer for you to read. RS over XY equals ST over YZ equals RT over XZ. And it doesn't matter which order you put them in, as long as the sides that are corresponding are in the same fraction. Now, we reduced all of those to the same fraction to show that they were equal. That fraction is called the scale factor. Okay, in example 1, our scale factor was 5/3. You could have also said it was 3/5. It just depends on which triangle you put on the top. So it could be that fraction, or it could be the fraction upside down. Either one would work. So for example 2, we want to write a similarity statement and we want to find the scale factor. So for our first quadrilateral, we'll just write it down any way we want to. Usually it's a good idea to go in alphabetical order if you can, but the key is that you are going around the figure. Okay, this wasn't as big a deal with triangles, because when you start at a point you only have 2 places to go anyway. But you need to make sure you're going around the figure. So this would be F, G, H, J. And we would just call this quadrilateral F, G, H, J. And it is similar to, now for the second one, we need to make sure we're matching up the correct angles. So F has 1 arc, so it goes with Z. G has 3 marks, so it goes with Y. H has 2 marks, so it goes with X, and J is a right angle, so it goes with W. So the first one was in alphabetical order. We skipped I because I looks kind of like a 1. But the second figure was not in alphabetical order, and that's okay, as long as they match up to the corresponding angles. Now to get our scale factor, we just pick any 2 corresponding sides. Doesn't matter which ones, because if they're similar, we're going to get the same fraction for all of them. So I'm going to do FG and ZY. Okay, FG is 20, ZY is 25. So when we reduce that, this reduces, both of them have 5 that go into them, so we divide the top and the bottom by 5. So this is going to reduce to 4/5. You could have done it in your calculator with math enter if you wanted to. And because we're not being picky about it, we also could have said 5/4. So we could have turned it over, and that would have been A-OK. Now for example 3, we're given our similarity statement. We know that ABCD is similar to QRST. And we want to find our scale factor and we want to find x. So again, to find our scale factor, let's just go ahead and pick any two sides. I'm going to use AD and QT. AD is 10, QT is 5. 10 over 5 reduces to 2. Don't write 2 over 1. If it's over 1, then it's a whole number, so we don't put the 1 on the bottom. We just write 2. So that would be our scale factor. We could have also had 1/2. So I'm going to make sure I circle both of those. Now to find x, this is where now you can think through this, and a lot of you will just try to process it in your brain without writing stuff down. And in this example, you'll get the right answer. But if this weren't x, if this were 2x minus 13, you wouldn't be able to do it all in your head. So I want you to get into the practice of what I'm about to show you. So our scale factor is 2, so let's call that 2 over 1, because now we're going to set up a proportion. The 2 goes with our bigger figure, so that's where x goes. And what corresponds to the x? BC and RS go together, so x and 4 go together. And then this is where we do something that's been a while since you've done it, but we cross multiply. So 2 times 4 is 8. 1 times x is x, so x equals 8. Sometimes once you get to that process, you'll have to start solving for x. You'll get just a regular algebra equation. You have to do a couple steps to get x by itself. But it's still the same process. Cross multiply and then start solving for x. Now, one other thing about similar polygons. Remember that the perimeter of a polygon is the distance all the way around it. The perimeters of two similar polygons use the same scale factor as the sides did. So if you know the perimeter of one figure, you can find the perimeter of a similar figure if you know the scale factor. So the two polygons have a similar perimeter, or a proportional perimeter. So in this statement right here, that's the perimeter because it's all the sides added together. So in example 4, we know that ABCDE is similar to FGHJK. We want to find the scale factor. Now, we only have one number here, that's AB, so we have to figure out which side goes with AB. Well, AB are the first two letters, so that's FG. So we know that AB and FG have to go together. They are corresponding. So those are the numbers we have to use. So we've got 10 over 15, and that's going to reduce to 2/3. Again, if you wrote 3/2, that would be fine. Just depends on which figure you start with. Now to find x in our next part, right, x, that's AE, so that has to go with FK, so x over 18 equals 2/3. Then we cross multiply. So 3x equals, and 18 times 2 is 36. Divide both sides by 3, so x equals 12. Now to find our perimeter, we know that our scale factor is 2/3. We could go through and find BC and find CD and find DE separately and then add them all together. Or we could find the perimeter of FGHJK and then set it up with our scale factor. So 15 plus 9 plus 12 plus 15 plus 18 equals 69. So we know that 2/3 equals, and I'm going to call this P. No, I'm not going to call it. I'm still going to call this P. And we're just going to call this perimeter over here instead of giving it a variable. Okay, P over 69. So we're going to cross multiply. 3p equals 2 times 69 is 138. Then if we divide both sides by 3, we will get 46. So that is the perimeter of AB, CD, E. So once we find that scale factor, we can not only find individual sides, but we can do the perimeter also. We cannot do the area directly though. Area is a whole different ballgame, so don't try that. So corresponding angles are congruent in similar figures, and corresponding sides are proportional. Remember, that means we can set them up as fractions that are equal to each other. So work on your practice problems and then make sure you get that mastery check done. Good luck.